Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a calculus student. This is a category of problems called related rates. And the reason it gets its name is we have a volume equation that depends on R, the radius of the hot air balloon. But R, the radius of the balloon, changes over time. So the radius is getting larger and larger. So that implies to me that somebody's blowing this balloon up. So what they want to know is the average rate of change in the volume with respect to time. It's a little awkward, right? Because we're just writing V as a function of 4/3 pi r cubed. So the only relationship we can describe directly would be the relationship between V and R. As R changes, V changes. But what we want is the relationship between the way V changes when time is changing. So we have to differentiate all of this with respect to T. So we're going to use chain rule here. We start by differentiating R with respect to R. You see the 3 is going to come out in front, so that's going to give me 4 pi r squared. But then we have to take dr dt because R is a function of time. Now we can see that R of t is 3t, so dr dt is 3. So this balloon is being inflated at a constant rate over time. So now we can just plug that in. And we're going to get 4 pi r squared times 3. So that's going to give us 12 pi r squared. Now, when t is 1, when t is equal to 1, r is going to be 3 times 1. So 3 times 1 is 3. And dv dt is going to be 4 pi times 9 times 3. If I'm doing that right. So that's 9 times, just do this on my calculator. 4 times 9 times 3 is 108 pi. So that's dvt at time 1. At time 4, r is going to be 12, because 4 times 3 is 12. So then dv dt is going to be equal to I see. I probably confused you a little bit here, so I didn't take into account this simplification, which is fine. So it's going to be 4 pi, r is 12 now, so it's going to be 144 times 3. So that's going to be 4 times 144 times 3 is 1728 pi. Okay, and then the average change is just the slope of the point of the line that connects these 2 points. So you have 1, 108 pi, and then the other point is going to be 4, comma 1728 pi. And so the average rate of change is going to be, we'll just call it m, because it's really just a slope, 1728 pi minus 108 pi over 4 minus 1, which is going to give us 1620 pi over 3. $540 pi. So that's the average change. It's if we wanted to get rid of the pi, we can just multiply by, put it in decimal. It's going to be 16, roughly 1696. Approximately 1696. So the volume is changing. Let's say we're measuring the radius in inches, so the volume would be changing 1696 cubic inches per second on average between time 1 second and time 4 seconds. And that would be the answer with units, and you should be using units here. I'm a little surprised that they don't put the units in the equation, in the problem rather. Okay, so that's it for this one. I hope this helps, and I'll see you guys next time. Bye-bye.